Jerry and Jim run a race of 2000 meters. First, Jerry gives Jim a start of 200 meters. What does this mean? Jerry gives Jim a start of 200 meters. So Jerry's like, Jim, you go ahead, you take a lead, right? You cover some distance even before the race starts. You reach that 200-meter mark, and then we'll start the race. So basically, when the race will start, you'll be at the 200-meter mark, I'll be at the 0-meter mark. And we both need to reach the 2000-meter mark. Right, so Jerry has given Jim a head start, some advantage. Jerry gives Jim a start of 200 meters and beats him by 30 seconds. So who beats whom? Who beats whom? What are we given here? And beats him by 30 seconds. So Jerry beats Jim by 30 seconds, right? Despite giving Jim an opportunity, or despite giving Jim a head start, Jerry still beats him. All right, that's one aspect. Beats him by 30 seconds. Hold on, beats him by some time? What does that even mean? Initially, Jerry gave Jim a start in terms of meters. Okay, that is easy to understand. But then he beat him by 30 seconds. What does that mean? 30 seconds, right? He beat him by 30 seconds time. How do we make sense out of this? Unless this is clear, it doesn't make sense to move on to the next statement. Beats him by 30 seconds. What does that mean? So what this means is that wherever Jim is, wherever the slower guy is, when the faster guy reaches the end point, wherever the slower guy is, from that point to reach the ending point, the slower guy would have still taken 30 seconds more. The slower guy would have still taken 30 seconds more, right? Jim required 30 seconds more to reach the end. And Jerry had already reached the end point by then. That's what beats him by 30 seconds means, right? Jim would have required 30 seconds more to reach the end point. Okay. So that's what's happening first. Next, Jerry gives Jim a start of 3 minutes. Okay. Separate situation, it seems. Jerry gives Jim, again, Jerry was the faster one. The faster guy gives the slower guy a start of 3 minutes. Start of 3 minutes, what does that mean? That, all right, it's 7 o'clock right now. You start running, and then I will start running at 7:03. That's what Jerry perhaps told Jim, right? You carry on running for 3 minutes. I'll wait here. And once 3 minutes are done, then I'll start running. So Jerry gives Jim a start of 3 minutes and is beaten by 1,000 meters. And it's beaten. Oh, so this time Jerry loses. This time the slower guy actually reaches the end point before the faster guy. And in fact, he is beaten by 1,000 meters. So at the time when the slower guy reaches the end point, at that time, the faster guy is only at the 1,000 meters mark. How did this happen? How come the faster guy is behind? Because of the 3 minutes head start. 3 minutes, it seems, was too much of a head start, right? It was so much of a head start that then the faster guy could not catch up, at least not within the 2 kilometers race. All right. Find the time in minutes in which Jerry and Jim can run the race separately. All right. So I have to look for two figures. The time it takes for Jerry, the faster guy, to run the race, and time it takes Jim, the slower guy, to run the race. And in fact, I can notice that in the answer choices also. In each answer choice, the first figure is smaller than the second figure. Again, indicating that Jerry is the faster guy. Right? One guy takes, for example, let's say option A, 8 minutes, and the other guy takes 10 minutes to run the same race. So of course, the second guy would be slower. Now, it's not written, but one thing we can directly apply, understand and apply, is that Jerry and Jim would have maintained the same speed in all these races. Had their speeds changed, then anyway, the question wouldn't make sense. Right? So whatever Jerry's speed was in the first race, whatever his speed was in the second situation, whatever his speed would be if he runs separately, they would all be the same. Similarly, Jim's speed throughout will be the same. Not written, but that much we can directly understand. All right. Now that we get the question, let's try to simplify it before we get into solving. So what have we discussed so far? Basically, in the first situation, when Jerry gives Jim a start of 200 meters and beats him by 30 seconds. So by the point, the faster guy reaches the end point. Faster guy, Jerry. When the faster guy reaches the end point, at that point, the slower guy, who's Jim, is behind. How much behind? 30 seconds. Right? Jim would have taken 30 seconds to cover this distance. That's what we know. Okay. In the other situation, who reaches the end point first? The slower guy reaches the end point first. At that point, where is the faster guy? Where is Jerry? He's at the 1,000 meters mark. Right? He's covered 1,000 meters, or there's 1,000 meters left. Since it's a 2,000 meter race, he's at the midpoint. Now, one thing, I'll use these things interchangeably. I might use the name Jim, or I might refer to him as the slower guy. And similarly, I might refer to the other person as with his name Jerry, or with the phrase faster guy. Right? So I hope that doesn't confuse you. All right. Now what? Again, we'll discuss two different approaches. First, let's consider an algebraic approach. Let me take some variables. What variables should I take? Well, I'm already given some information about the distances. I'm given some information about the times, so it makes sense to take variables for their speeds. All right. So let me assume Jerry's speed is f meters per minute. F for the faster guy. Meters per minute. Why did I take meters per minute? Because that's what we're dealing with, right? All the distances are in meters, and all the times, well, most of the times are in minutes, and eventually I need to figure out the answer in minutes also. So instead of first assuming meters per second and then converting in the end, let me just start with meters per minute. There's one figure in seconds, but that's 30 seconds. I can easily convert that into minutes. All right. So let's assume Jerry's speed is f meters per minute. Jim's speed is s meters per minute, right? The slower guy. All right. What then? Now I'm thinking in the time the faster guy runs the 2000 meters, the entire race. In that much time, how much distance does the slower guy run? In the time the faster guy runs 2000 meters, how much distance does the slower guy run? How can we figure this out? Now, let's understand. Let's say this is the entire track, 2000 meters, right? Start and finish. How much distance was run by the slower guy in the time that the faster guy finished the entire race? So what happened initially? Initially, the faster guy is waiting. He's like, you go ahead, you reach the 200-meter mark, and then I'll start. So anyway, I will not count this distance of 200 meters, right? That much distance was run even before the actual race started. I won't count that. What else? By the time Jerry reached the end, Jim had reached some point in the middle. What point? A point from where he would have taken 30 seconds more to reach the end point. So how much distance did the slower guy run? Well, whatever is left in the middle, right? The entire track was 2000 meters. Of those 2000 meters, I'll subtract the 200 meters, right? That much was run even before the race started. I will also subtract this distance. How much is this distance? Well, we've taken a variable for a speed, so speed into time will give me the distance. So minus s times 1 by 2. That's the distance that the slower guy will run in the time the faster guy finishes the entire race. Okay. Now, this is one piece of information that I'll keep separate. I'll use it later. All right. Now, what's going on in the second situation? In the second situation, again, what are we dealing with? What I'm saying here, let's be very clear about this. In the time the faster guy runs 1000 meters. So what's happening? Jerry gives Jim a start of 3 meters and is beaten by 1000 meters. So Jerry's first like, you go ahead, run for 3 meters, then I'll 3 minutes, then I'll start. And then when he starts, he's only able to run for 1000 meters. And by that point, Jim has reached the ending. So in this duration, in which the faster guy runs 1000 meters, in that duration, while the faster guy is running, parallelly the slower guy is also running, how much distance would the slower guy have run? He already had a head start of 3 minutes. So from the entire distance of 2 kilometers, I will subtract the head start because he was able to reach the end point. So that's why I'll count the entire distance of 2 kilometers, right? So the slower guy from the entire 2000 meters he was able to reach the end point and he already had a head start of 3 minutes. So from 2000 meters, I will subtract this head start distance. That will give me the distance that the slower guy would have run while the faster guy covered 1000 meters. What would that be? 2000 minus this distance. What is this distance? Well, 3 minutes, and his speed is again s meters per minute. So 2000 minus 3s. What's 3s? The head start, basically. 3 minutes times the speed, that's the head start. And then 2000 is the distance for the entire track. 2000 minus the head start. That's how much distance the slower guy would have run in the time it would have taken the faster guy to run 1000 meters. Vartika SK, is the second situation clear to you guys? Okay, Vartika, then maybe we'll discuss in the end. Or maybe you can go through the video again. Huh? All right. So why am I dealing with these? Because one thing I noticed initially, that in the second race, the faster guy is running 1000 meters. That's a very interesting figure. That's the middle point, right? So I wanted to use that. I wanted to use that characteristic, that he'll reach the middle point. He's only able to reach the middle point in the second race. Now, tell me, how would these times compare? What are the times? The time the faster guy takes to run 2000 meters, how would that time compare with the time the same guy takes to run 1000 meters? How would these two times compare? What do you think? how would these two times compare? One time is twice the other. One time is twice the other. Okay, right? To cover 2000 meters, he'll take double the time of what he'll take to cover on 1000 meters. Now, as a consequence, how much distance will the slower guy cover in the time? This time is twice, right? 2 times the time. And here the time is half. So correspondingly, the slower guy in the first situation will cover double the distance compared with how much distance he's covering in half the time. Right? Since the time is getting halved, correspondingly, the distance run by the slower guy in that much time will also be half. So what I can do now is basically I can say that this A, 2000 minus 200 is 1800. 1800 minus half S equals 2 times 2000 minus 3S. What I have basically done is A equals 2 times B. How did I get there? By first realizing that the faster guy would take double the time to cover 2000 meters compared with 1000 meters. And in twice the time, the slower guy would run twice the distance compared with how much he runs in half the time. So that's how I get this equation. 1800 minus half S equals 2 times 2000 minus 3S. Now it's a matter of solving this equation. Right? I go about solving it. I take the S's on one side and everything. I eventually get the speed S is equal to 400 meters per minute. That's the speed of the slower guy. So in terms of minutes, how long will the slower guy take to cover the entire race? It's a 2000 meters race. So he's running 400 meters per minute. He'll take, for 2000 meters, he'll take 5 minutes. I could go on to calculate the speed for the other guy also, but I glance at the options and I realize if the slower guy is taking 5 minutes, actually option A, C, D, and E are all wrong. Right? He's not taking 10, 9, or 10 minutes. He's taking 5 minutes. So anyway, all the other options are wrong. And that already tells me that the answer is B. Of course, the key here was to set up this whole thing, right? How to think about, oh, I could set up this way to consider how much distance is the slower guy running in both cases and compare that. Right? Once I set it up, then it was a matter of just solving the equations. But then the key was actually realizing this is how we could set it up. Right? For me, how I got to thinking like this was by understanding that in one case, the faster guy is running 2000 meters, in the other, he's running 1000 meters. I use that to my advantage. We'll discuss one more approach, and then if you have any questions, we'll take them up. All right, same question. Let's consider another approach. Now, before anything else, just by looking at the first situation, Jerry gives Jim a start of some distance and still beats him by 30 seconds. That already tells us that Jerry is faster. Right? Jerry's faster. That much, I hope, is clear to everyone. Right? Jerry's faster. He's giving a head start to the other guy and still he's able to beat the other guy. So he's certainly faster. Now, based on just that, one thing we can directly realize is that in the time, the faster guy covers 1000 meters. In whatever that time is. In the time, the faster guy covers 1000 meters. Correspondingly, how much distance will the slower guy cover? More than 1000, equal to 1000, or less than 1000 meters? In the time Jerry covers 1000 meters, Jim will cover less than 1000 meters, indeed. Right? Because Jim is slower, Jerry is faster. Okay. Why is this relevant? Well, I'm looking at the second scenario in which we are given that Jerry gives Jim a start of 3 minutes. Right? Jim gets a start of 3 minutes and is beaten by, Jerry gives Jim a start of 3 minutes and then Jerry is beaten by 1000 meters. Now, let's understand. Start point, end point. Let's say we're talking about Jim and Jerry here, right? So the slower guy had been running for 3 minutes. He reached a certain point, right? I've shown that in the figure. In 3 minutes, he reached that point, wherever that point is. We don't know yet. And then afterwards, he covered the remaining distance. Now, in the time that Jim covered the remaining distance, in that much time, how much distance had Jerry run? When the race basically started, when both of them were running, from that point till the time when when the slower guy reached the end point, how much distance had Jerry run? 1000 meters. Exactly. Right? The slower guy had covered 1000 meters. So tell me, based on just this much, from this point till the end, how much would this distance be? More than, less than, equal to 1000 meters? Can we comment? This distance would be less than 1000 meters. Right? Because this both happened in the same time frame. And of course, the faster guy would cover more distance. The faster guy is covering 1,000 meters, so the slower guy would cover less than 1,000 meters. Now, one more thing, the entire track is 2,000 meters. Of that track, in the first 3 minutes, the slower guy had already covered the first leg, right? One portion he had already covered and one portion was left. How much was left? 1,000, less than 1,000 meters. So how much would he have covered in the 3 minutes? In the first 3 minutes, he would have covered more than 1,000 meters. All right, this is quite interesting now. What I started off to do was, I started off to get an estimate of roughly what the times might be like. So that's what I'm still trying to do. The slower guy would have covered more than 1,000 meters in 3 minutes. The slower guy would have covered more than 1,000 meters in 3 minutes. Based on just this piece of information. How much distance, or rather, how much time would the slower guy take to cover 2,000 meters? For 2,000 meters, Jim would take how long? I don't need an exact figure, but can we get any estimate? Let me ask you this way. Yeah. Compared with 6 minutes, where would he be? Would he take equal to 6 minutes, more than 6 minutes, or less than 6 minutes to cover 2,000 meters? He would take less than 6 minutes. Why? Because he's covering more than 1,000 meters in 3 minutes. So in 6 minutes, he'll cover more than 2,000 meters. In other words, to cover 2,000 meters, he would take less than 6 minutes. Just this much. Now, if I go through the answer choices, well, Jim's figure has to be less than 6. I scan the options. There's only one answer choice that matches. So that's the right answer. And we are done. We're actually done already. Was it lucky that the answer choices worked out this way? Well, maybe. But then I didn't tweak the answer choices. These are original official questions answer choices, right? Worst case, I'm sure we could have eliminated at least 2 or 3 options, if not all. But also remember that our foremost objective, in case you guys are wondering, yeah, but what if there were other options that were less than 6 also? Realize our foremost objective is to answer the question on the screen. That's our foremost objective. And we'll try to do that in the most efficient way that we can. After that, we can think about variations and everything. But if instead of answering the specific question on the screen, we are thinking, okay, forget about the options. Let me just answer the question, assuming the options could change in the future also. Then we're not doing the justice to the question. Then we're not using the resources that are there at our disposal.